Hi, this is another example problem related to finding the moment of a force about an axis. So in this problem we have a 30 kilonewton force acting on this bracket as shown. So the question is asking us to determine the moment of the force about the AA axis. This is the AA axis. And the angles are alpha is 60 degree, beta is 60 degree, and gamma is 5 degree. So these are the angles of the force and makes with the x, y, and z axis respectively. So in the second part of the question, we are asked to find the coordinate direction angles of the force F equals 30 Newton in order to produce the maximum moment about the AA axis. And what is this moment? So maximum moment. Okay, so as for the solution, so let's write F in a Cartesian form. So we have F vector to be F times the unit vector. So since we're given the angles, this will be 30 Newton times cosine 60 degree R plus cosine 60 degree J, okay, and plus cosine 45 degree K. Right, and that will be equal to, that's 15I plus 15J and plus 21.2K, and our unit is newtons. Okay, and so we need a position vector to find. Let's recall. So the moment A will be equal to a unit vector along AA, dot product, and a position vector cross product times F. Right, and this moment will be a scalar value. So our R will be here a vector that is starting from the A-axis and ending at the start of the F vector, so that's our R vector. And that is expressed as, so the coordinates for R will be minus, so if this is the x-axis, so it will be 0.1 for the x-axis, and the z component of the R vector will be 0.15 meters, so this 50, that's 100 millimeters. And as for the UAA, since it lies on exactly the y-axis direction, so it's simply a J. So let's write down the R vector here. So it is going to be minus 0.1 I plus 0.15 K, and the unit is meters. Okay, right, and our U vector that we'll be using for this dot product operation, that is simply J. Okay, because it lies on the axis that we're interested in is the AA axis, and it is simply it is located on such that it lies on the y-axis direction. Right. Okay. Let's continue with the dot product operation. Alright. So we're going to be having moment A, that will be determinant of ux, uy, uz, rx, ry, rz, and fx, fz. That's the determinant. So let's write down the values for this matrix. So for the u, I'm going to have 0, 1, and 0. For the rx, I'm going to have 0 0.1, 0, and 0 0.15. It's minus. And for the force, I'm going to have 15, 15, and 21.2. Okay, and that will give me a scalar value of 4.37 meter on my moment. Okay. And the second part of the question is asking to find the orientation. Okay, orientation of the force vector. Force equals 30 Newton vector such that I get the maximum moment around a axis. Okay, so that's the question of the second part. So for a moment to be maximum, I need to have a perpendicular orientation of f with respect to u and r. Okay, so my f vector must be perpendicular to u vector and the position vector. Right. So essentially we're talking about so that if this is my x-axis and this is my z-axis, if we go up, so this f vector should be perpendicular to my r vector, such that I get a maximum moment, and also should be perpendicular to it should lie on the x and z plane. So I got beta equals 0. Right? It should be perpendicular to the y-axis, and it also should be perpendicular to the position vector r, which may be regarded as the moment arm. Okay. So based on that assumption, my position vector, so if this is where my pipe is, actually where my pipe is, if I assume that, so perpendicular to the plane of to this plane that I'm writing on, is my y-axis or the AA axis. So I'm going to be having a r 0.1 in the x direction and 0.15 in the y direction, and I'm going to be having my r to be like that. Oops. Okay. So that's my r, and the magnitude or the length of that r is like the hypotenuse of this right angle triangle. So that is 0.18 over 3. Okay. So my force vector should be perpendicular. Okay, so this F equals 30 Newton should be perpendicular to that, and also perpendicular to my y-axis. So my force vector lies on the x-axis plane. Okay, so if this is 0.1 and 0.15, my force vector orientation will be like 0.1 here and 0.15 here. So based on that, I can continue writing my the force vector, the unit vector for this force vector. So in the lineup, so that unit vector UF can be written as, so for the x, I'm going to be having 0.15 over, so it's the cosine 0.15 over 0.1803i, and I have a 0 for j, and for k I'm going to be having 0.1 over 0. Okay, k. So remember, essentially this is cosine alpha. This thing is cosine gamma. Okay, I'm simply writing a unit vector, and let me see, this unit vector UF, that will be 0.832 I plus 0.554 K. Okay, so that is my unit vector. So based on this unit vector, let's go back to the question. So I'm asked to determine the coordinate direction angles of F. Okay, so it's essentially what I've just written here. So cosine alpha is this one. So this is cosine alpha. And this is cosine gamma. So based on this, alpha will be cosine 0.832, and this will give me alpha 33.7 degrees. Okay, and similarly, my gamma will be cosine this value 554, and my gamma will be equal to, let me see, 56.3 degrees, and of course my beta value is 0. So that was the initial assumption. Okay, and what about the moments? The moment, the maximum moment here, it is simply 30 times. So it's a scalar calculation. So moment, I don't need to do any cross product, dot product. Okay, simply 30 times this moment time. So it's 30 times 0.1083. So that's meter, that's Newton, and that makes a moment max. So maximum moment will be 5.41 Newton meter. Okay, so based on my F equals 30 Newton, and based on this orientation, alpha, beta, gamma, I got a maximum moment around the axis AA. Right, and this concludes the solution of this problem. Thank you.